Hey everybody, excuse me, Mr. Taylor here. Let's get into the algebraic terminology for our look at these transformations. For the most part, we've done that, but just let you see now. So we're not going to be cutting and pasting or whatever. We're going to look at pretty much the way I was solving them from either changing the signs or multiplying by a -1 or adding something to x or adding something to y, vice versa. So here this is, we're still in Unit 5. This is 12.4, uh, and we're looking at the algebraic representation of translation. So let's get it on. Your learning objective is you will find the vertices after a translation and then graph the translation and its image. Uh, Vocabulary didn't change, so no key vocabulary here as we go forward. The author says that these rules in the table describe how coordinates change when a figure is translated, either up, down, right, or left. So here's what the rules say. The rules say, and let me get my little pointer. Well, never mind. We'll go here. It says that if you're going right so many units, that's what A means. You add A to the X coordinate. So just like the arrow right here says, if you're going right, then it's going to be X plus some number, comma Y. And it says if you're going left so many units, then you subtract that number from your X coordinates, right? And so that means you'll have X minus some number, comma Y. It also says if you're going up B units, so that means you're going up. That means you're adding to Y. Then of course you would add whatever that number is to the Y coordinates. So it'll be X comma Y plus that number. And if you're going down B units, that means you'll subtract that number from the Y coordinates. So here you'll look at X comma Y minus B. You be very, very sure that you understand your rules of integers in this situation here. Okay, let's see. So the author gives us triangle XYZ, and it says it has vertices X as 0, 0, Y at 2, 3, and Z at 4, 1. Then it tells us, well, find the vertices of X prime, Y prime, Z prime after a translation of 3 units to the right and 1 unit down. So what you're going to do, here's our original, X, Y, and Z. Is our original or our pre-image, is I think is what the author wants us to call it. So here's our pre-image. So the rule here says we're going to go 3 units to the right. So remember what we said back here. If we're going 3 units to the right, then we're going to add. So we go back and we will add to X. But it also says we're going to go down 1 unit. So what do the rules say? Let's go and subtract from Y. Okay, so what we're looking at here, and as you can see, the rule should be X plus 3 comma Y minus 1. So 0, 0, we have 0 plus 3, which will give us, for X prime, 3, comma 0 minus 1, and again with those integers that gives us a -1. So we move down to Y. So Y says 2 plus 3, which is going to give us the new X coordinates for Y prime as 5, and then it'll be 3 minus 1, which gives us a new X coordinates and Y coordinates for Y, which is 2. And here we have Z, so we take the X coordinate from Z, add 3, that gives us our Z prime X coordinate is 7, and then a -1, -1, add the ones, keep the sign, and that gives us a -2 for the y coordinates. Okay, so when we look at step 2, now of course we just go back and plot what those ordered pairs were for x and for y and graph. And as you can see, the orientation didn't change. It literally just slid, and believe it or not, it's this line that it slid on. Let me move it. Is the origin. All right, let's now see, can we work a problem. So what I want you to do is write this down, stop the video, and look at this rectangle that has the vertices of 0, -2, 0, 3, 3, -2, and 3, 3. And what is the coordinates of the vertices of the image after the translation? And what it's telling us is we want to subtract 6 from x and subtract 6 from y. So you go ahead and stop it, work that, and then when you're done, come on back and we'll try and see how we did. Okay, so here we go. This rectangle. So I've already gotten the answer here, but let's see, can we come in here real quickly and determine how we got one or two of them. And I know you read along there with me. So we can see how we got a couple of them maybe. So I'm looking at, it says x. So let's look at the very first one, which is 0. So it says subtract 6. So that'll be 0 minus 6. That's our x, comma, and we have, what did it say do for y? It says subtract 3. So we have -2 minus 3. So that's the first one we look at. So what do we get out of that? We get 0 minus 6, which is -6. And we get -3 minus, or should I say 2 plus 3, and then keep your negative sign, which will give us -5. Okay, then we take a look at the other one real quick. We have 0, 0. And then again, we're going to subtract 6. And then we have 3. And from 3, we're going to, it says subtract 3. So all we got to do now is do the math, find the new coordinates for the image. And again, this will be -6. And here, 3 minus 3 will give us 0. Okay, let's take a look at the other one, which is 3. So we'll have 3 minus 6, comma, and then we will also have -2 minus 3. That's familiar. We've seen that up front there. And what will we have? Well, 3 from 6 is 3, but because 3 is greater, we keep the negative sign, and then of course 2 and 3 is 5, and we keep the negative, and that's what the rules say, and we get -5. The last one, we have 3. So again, it says subtract 6 minus 6, comma, and then we also have y is 3, subtract 3, and we get -3 and 0. So now the only thing we need to do now is take those original points here and graph those, and then come back with the original, these image points, and graph those. All right. If you have any questions on that, please leave a comment or bring them in for us, and we'll discuss them a little bit later. Pretty easy. You're just doing integers, adding and subtracting when you are translating, and everybody should be able to do that with no problem at all. All right. Thanks for looking. This is Mr. Taylor. I'll talk to you soon.